At this point, we have all the necessary building blocks to have our merge sort algorithm. We defined a split function, we defined a merge, and now we will define the merge sort function. So in Python, we're defining the merge sort function that will take a list as an input. I'm using this counter here just for demonstration, so we can see how many times the recursion happens. So it's not necessary for the algorithm to work, but it's just to show where we are at which part, how many times we did a recursion, just to use in combination with these log messages, which are also not necessary for the algorithm, and they're only present in the Python part of the code. So this is the base case of the recursion. So if the list that we're passing as the input argument is a list with one element, the list is sorted, and we will return the list. So this is what's happening at this part here. Then, if the list is bigger than 1, so we will reach this point, and we will split the list into a left and a right list. So we're using the split function. We're passing the list input of the merge sort as an argument, and we're returning two lists, the left side, the right side, or the first half and second half. Then here is the recursive part, and this is why it's important now, the counter and the logging, because it can be very tricky to understand recursion. At least I find it sometimes really tricky, not so trivial. So here we split the list into two, and then we will sort. We will call the merge sort function again for the left side, and this is it will return a capital L, and after it we will call the merge sort recursion with the right side, and we will store it in the R, capital R. So when it comes here, so if we have a list of bigger size, we will split the list like we demonstrated in the Wikipedia animation. So we will we will split the list until we reach a list with single elements, like we're doing here, and then we will merge the single elements, and then when they are merged and all of them are coupled, then we will merge again. So this is the recursive part. Let's go back here to the Python merge sort, and then this is the part. So we were splitting until we reach a list with one element, then we will merge them. So let's run the cell, Shift Enter, define the merge sort function in Python, and let's start with a very small test vector so we can try to understand what's happening inside the merge sort function. So here's our input list, so it's unsorted, and we want that the result will be 1, 2, 3. So let's run it. So here we are inside the function merge sort. The input arguments are 2, 3, 1. We reach the point where we'll call the split function, and we're passing the 2, 3, 1 as an input argument. We are inside the function split. This is, we calculate the index of the middle point. So it's here, we will split here. So we're returning two lists. So one is a single element list, and the other one is 3, 1. And then we're exiting the split, and we're calling the function merge sort for the left. So we're at this point here. So we are now inside the MergeSort function. This is the second time. The first time was when we just called it. So now we're the second time with different input arguments. So we're entering the MergeSort now, and because it's a list with one element, the input list length is smaller than 1, so we will return the list. So we reach this point here, and we return the list. So this is here. And then we reach this point where we're calling the MergeSort for the right, which was the result of the split. So it's here, so we're passing here, and then it will call this, because it's bigger than 1, the length, it will call the split. It will split the 3 and 1 into 2 single element lists, and then we will exit, return this 2 lists, and we will exit the split function. We will call for the left side, it's smaller than 1, so we will return 3. Then we call for the right side, it's smaller than 1, it will return 1. So we reach this point where we will merge the single element. So we will merge the 3 and 1. So we're calling this, we're exiting the MergeSort, calling the merge function, and now we will merge the 3 and 1. So 3 is bigger than 1, so we will append 1, and then we reached the end of the list, and we will append the 3. So this is the output of the merge function. And now we will enter the merge function again, because we will merge the 2, which is the output of the call to the left side, and we will merge with the output of the right side. So this is what we're doing here. We're calling the merge, then we will 2 is bigger than 1, we append 1, 2 is smaller than 3, we append 2, we end the, we reach the end of this list. This is missing, so we append here. We will exit the merge, and we will have the result, which is 1, 2, 3. So after this, we will return the output 1, 2, 3, which is the sorted list. So let's try it with a more complex test vector, but I will not analyze, but just to show the result. So it entered the recursion many times, so it's already 6 times, and it will split everything, merge, and in the end we have the result 1, 2, 3, 4, 4, 6, 7, 27, 55. So this is the output of the MergeSort function. This was the input argument was an unsorted list, which we can see here, and we can, if you take a look in the log, you'll see step by step of what's happening. And so this was the implementation in Python. So this is the same thing in JavaScript, same recursion. We're splitting. This is the base case for when the list is sorted, because it's a list with one element. So we can define in JavaScript and we can test. So this is the unsorted input, sorted output. We do the same thing in C++. So we define the MergeSort function and we test. So we get the sorted version. This is for Java. As you can see, it's very similar. The way we're just using the data structures and the functions of each programming language, but it's the same algorithm. And there are different ways to try to explore characteristics and the unique characteristics of each language, but also for demonstration purpose and to understand the algorithm and to understand implementations in different programming languages. I try to do so the implementations are very similar to each other. So let's define our function in Java, and this is the result. So here we have the implementation of the MergeSort algorithm in 4 different programming languages. So next is just a bonus. I will not do this for the other notebooks in this series, but I found it to be interesting. I recently discovered this Jupyter kernel gateway, and we can start a web server and convert Jupyter Notebook to be a kind of a REST API server, and we can use the algorithm we just implemented as a microservice.